here. And honestly, guys, that's fine. That we'll try to do stuff outside, especially as it gets nicer, closer. You know.
You gotta put some salt down out there. Slippery.
I know. You must, I'm glad you didn't fall.
I did fall.
Oh, you did? I didn't know she went all the way down. I saw you, and you were just like still like this. So like I thought you. Oh.
Because it's slippery. Why else would I fall?
I didn't slip once. I was running backwards for the last leg of
the So, okay, guys. Okay, so we will go outside again when it's nice out, and this is perfectly fine to be nice. But once it gets like actually nicer, we can probably go out and actually do math outside. We do a lot of times bring the whiteboards, which is really helpful. I was gonna look into maybe some sidewalk chalk as well. We could do math in the parking lot or something, but
just be a bunch of math in the middle.
I know it'd be like.
Then they think they're smart.
Why put letters in math?
The little kids walk out. Why some trigonometry? This is foreign language.
Okay.
There's letters in math.
So. Okay, guys, let's talk about this next problem. So this is similar to what we're going to be doing for tomorrow. We're not doing weight loss tomorrow, but this is kind of an example of but we're it shows the weight loss per week of a dieter. So like someone's trying to lose some weight here in this problem. Now this is not trying to talk about any, like, so don't think anything about weight here in terms of like what it says or whatever. So I'm not trying to like promote weight loss or whatever. But the time in weeks compared to their weight. So they're trying to lose some weight over time. We're going to talk about if that trend continues, can we make a prediction about how much maybe they lose over, if they have a goal to what they want to lose. So it says find the equation of the line you best think fits this data. So again, this data is pretty straight, but like with weight loss, it's not always like exactly like you lose 5 pounds per week and that's it. You know, like doesn't work that way. It's more gradual, or some weeks are better than others, or just kind of how things go. So we're going to draw a line here. So I'm going to try and draw our line in. You guys can do the same. And again, I don't want to have my line just go through like maybe just a couple of the points. I want it to go through the trend. So kind of through the middle as best I can. So there's some points above, some points below. Kind of get that equation down. They want the equation of the line that you think best fits this data. So we're going to go through the steps we did on the front side. We have to find a slope, but that means that we have to go ahead and pick a couple points to use to work with. So I kind of like this first point, the 0, 180, because that's actually our starting point. It's kind of a nice point to work with. So we start at 0, 180. What other point do you guys like? The 5, yeah, it kind of works out nicely. I like that 5 and 170 because that's a nice point. If I picked anything else, it's going to end up being like a or like a, not a nice whole number. So let's use that one because it works nicely. Yeah, the 3, 175 is pretty good too. So we have to find the slope. So we're going to do y2 minus y1. So I'm going to do 170 minus 180 over 5 minus 0. So get negative 10 over 5. So that's really what? Careful, negative 2 over 1, right? So our slope is a negative 2 over 1. When we're talking about this, what does that mean about our weight in this case? It's going down how much? 2 over each week. So every week this person is losing 2 pounds per week, which sounds like, like a safe weight loss here. So negative 2 is our slope. Now we want to find the b. Does anyone know a fast way in this case to find the b? Yeah. Look at the 180. That's our starting point. That's our y-intercept. So if you wanted to substitute values in, you could. But I actually kind of know the b, I do know the b already. That's our starting point. That was the starting weight. So that was 180. So our equation is negative 2x plus 180. So it says, let's find, and now, okay, so real quick, just a little caveat to that, is if you pick two different points, your equation might be slightly different, and that's okay. That doesn't mean you're wrong. I'm guessing your slope is somewhat close to -2, and I bet your b is somewhat close to 180. So just so you guys know, it doesn't have to be exactly the same. Yes? I think if it flipped then, I think it should be -3 over 1. Oh, but these go down, those are 5 units. So real quick, I just want to point something out. So really good question that Clayton had. He was using, he kind of used just the graph. So he went down 1 and over 3, and that's okay, except down 1 isn't down 1. How much is he actually going down? Do you guys see it? He's actually going down 5, so it should be down 5 and over 3. If you want to do it that way, that works. But it just, understanding that depending on your scale, your graph isn't, you can't just always just count the blocks. Now they want us to find the dieter's approximate weight after 10 weeks if this pattern continues. How would we figure that out? How would we find their weight after 10 weeks? Because that doesn't show up on the graph. How can we figure that out? Any thoughts? Yeah, so this is the x. This is saying x is the number of weeks. So they're saying put that value in for x. Let's try and see what that value is after 10 weeks. So it'd be 160 and 160 what? Pounds. All right, the next question is kind of a weird one. I want you to actually think about it. Could this pattern continue for a whole year? Explain. What do you guys think? I'm seeing some people shake their head no. Why not? If this continued for a year, how many weeks would that be? How many weeks? There's 52 weeks in a year. If they're losing 2 pounds per week for a whole year,
She'd weigh nothing.
yeah, he or she. Of course, that's totally like culture that we think it's a girl, automatically, but it could be a guy too. But that 52 weeks, they lose over like 100 pounds. Like, unless this is a really, really small person, like very short, that's not like a healthy weight. Like, hopefully they're not losing that weight for a whole year. I mean, they didn't start at a point where this isn't like the Biggest Loser competition here, where they're starting at some, very large weight. Hopefully they wouldn't want to do that for a full year, because at that point, if we put 52 in as our x, we do -2 times 52 plus 180. This is -104 plus 180. They would weigh like 76 pounds, and I don't know many of us that's a healthy weight for them. So that's a little much, I think. So no, that would not make sense. And just even the idea that like at some point things might slow down. Like you can't keep that up, that weight loss, and just isn't healthy. All right. Some of what we're going to be doing today is going to be like example 3, where they graph the points for us, and we have to write our line of best fit. And then some of them are going to be like the one on example 4. I actually want to go down to example 4 and help you guys to see how to set something like this up. So This next one is just talking about the amount of practice per 3 throws they make. And obviously the more they practice, the more shots they should make. Now, I want to talk to you guys a little bit about how to set up a graph if they don't do it for us. So I think most of you guys are probably pretty good at this, but I want to make sure before I send you on your way. So a lot of the graphs I'm going to give you, I think actually all of them have this type of graph. Now, if you prefer the 10 by 10, you can use that, except on a problem like this, this graph is going to be better because I don't want my axis right in the middle, because if you notice, there's no negative values. It doesn't make sense to have negative values in this problem. We're talking about years since 1988, so like years after 1988, and then the vertical drop of a roller coaster. So a vertical drop is that first drop, you know, when you go down the tick, 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 and then it drops you. This is not, that's not going to be a negative number ever. So when I go to make this graph, I'm going to want to use just the X and Y axis like as a kind of an L-shaped graph, kind of back when, before we started talking about negative numbers, back when you first started graphing. Now, the top line is always going to be your X values. So that would go across the bottom. And then the Y values is going to be the vertical drop in this case. And I want to show you guys a few little things that I might suggest you do. So as you're doing this, you have to do a little bit of planning. So I want to go from 1 to 15 on the bottom. Yep. Yeah, so yeah, doing some planning ahead of time, because if I just start counting this 1, 2, 3, I'm going to run out of space. I'm not going to be able to fit my 15th one on there. So Clayton already looked at it and he said every other one works really well, right? Like so, or like go like 2, right? Is that what you're going to do? 4, 6, 8. So sometimes counting up by different values, so 2, 4, 6, 8, you just go up by even numbers. But you can't change the spacing you use. So you couldn't just put these numbers across the bottom. So I couldn't go skip 2 spaces and then skip 3 and then skip 4. You know, like you can't change your skips. So you have to stay consistent. So this would have to be 8, we go up that way. That's one way, because I don't think you'll fit 15, right? Oh, you're super close. That's kind of annoying how close you are to 15. So maybe you could if you like kind of moved it over a little bit. Now the vertical drop, do I need to start at 0? We're not talking about baby rides here, like where they they just take the little guys around the circle in the little car that they can't really drive. But, so we can put a little break in this graph. And so what that's, like, we took the graph and like kind of smushed it together. We could start at 150 right here. So I can put a little break in the graph, and you want to show that with kind of like a little like zigzag that shows that you took part of the graph and you smushed it together. And then again, a little bit of planning to figure out, I want to get up to 400. But I don't want to just skip, like as I kind of have to do some planning. Maybe go up by, it's 250, so go up by like 25s or 50s or something. This was 200, that's not probably enough. So we'll probably go up by 25s maybe. So kind of do a little bit of planning. So sometimes I'll do this and then I'll realize I didn't do a good job of planning. So like if you guys look here, I think this is bad. I'm going to run out of space. So sometimes I have to kind of monkey around with it a little bit and try to figure out what works best. So I might just go like 200 here. This would be 250, 300. Does that work? Go up by 50s? That works, right? Yeah. 400. So kind of just doing a little bit of pre-planning as you guys are doing this. So using pencil, kind of trying to make plans to make sure as much of your graph can be used as possible. Because if I have this graph all shrunk down in the little corner and I have these little dots right here, it's going to be really hard to make a line of best fit. But if I can have this kind of stretched over the whole graph, that's going to be helpful. So a little bit of pre-planning as you guys are doing this. Now we're not going to actually do this whole problem. It takes a little while. And the data is so old that at this point it's probably not the best data in the world anymore. But I like talking about in terms of the graph. What's that? You think it's the, I don't know what, you can Google it. Yeah, I know, we got Google. If only there was a way to find the answer for that. What's the largest roller coaster drop? So our homework is listed here for you guys. I'm going to get you guys some graph paper. Again, the graphs I'm going to give you guys are kind of those more generic graphs. So that you guys have, what's the longest drop? 400. Yeah, so like once they got past 400, they didn't really get much further. Get you guys some graph paper. Pass those back. Yes. And I don't think you'll need all these graphs, but I figure giving you guys more is better than less.